Next, let us come to this one. The application of that double integral. So how to evaluate this one? Double integral xy into x square plus y square dx dy over the rectangle bounded by the line x is equal to 0, x is equal to a, y is equal to 0, y is equal to b. For example, now here you can draw this graph. This is the line x is equal to 0, that is the y-axis. This is y is equal to 0, which is the x-axis. Suppose x is equal to a is this one. So that means it is bounded by this one, and then y is equal to 0, this one, and y is equal to b. So y is equal to b. That means what will be the area of this region using the method of double integral. So here how to evaluate this one. If I denote this region E, so double integral xy into x square plus y square dx dy over the region E, which is this rectangle only, bounded by x is equal to 0, x is equal to a, y is equal to 0, y is equal to b, is equal to, that means the limit of integration for x will be from x is equal to 0 to x is equal to a, and for y it will be from x is equal to a to y is from y is equal to 0 to y is equal to b. So this is equal to integral 0 to b integral 0 to a xy into x square plus y square dx dy. In this case, since the limit of integration is a constant number only, so you can either integrate it with respect to x first or with respect to y. So here I'm going to show you that we will integrate this one with respect to x first. Okay, so you can integrate with respect to y also, it doesn't matter. So now here this is equal to integral 0 to a. Then now here you see that when you integrate with respect to x, the limit of integration is from x is equal to 0 to x is equal to a. What you need to do is you have to keep this y as a constant. So or consider this y as a constant. Now here you see that I can bring this since y is since y does not depend on x, so and act as a constant, so I can take it outside. So it will be integral 0 to a x, then x square plus y square, this will remain there, dx into y dy. So let us integrate this one. It will be integral 0 to b, then what is the integral of this one? X into x square will become x cubed. Integral of x cubed with respect to x will become x to the power 4 by 4, plus now here x into y square dx. Y square will act as a constant, so integral of x will be x square. So it will be x square, then y square will remain as it is, then by 2, then into y dy, where the limit of integration is from 0 to a. So for x you have to replace this limit of integration. It will be 0 to b, then replace x by a. So it will be a to the power 4 by 4 plus a square y square by 2 minus the lower limit. It will be 0 because you replace x by 0 here, x by 0, so the whole thing will be 0. So that lower limit term will vanish. So into y dy. So now this one is integral 0 to b, then you'll get a to the power 4 by 4y, multiply this y, plus a square y square into y will become y cubed by 2 dy. So this is the integral, now a single integral with respect to y. So where the variables here involved here now are only in terms of y. So you can easily integrate it. Integral of y will be y square by 2, integral of y cube will be y to the power 4 by 4, and substitute the limit of integration. The upper limit will be b and the lower limit will be 0, and then you'll get the answer. So that means the value of this double integral will give you the area of this region bounded by x is equal to 0, x is equal to a, y is equal to 0 to y is equal to b. So the final value of this one will give you the area of this region. You can see that what will be the final value of this one, because I've already sent the notes. So from there you can see that what will be the final value of this one. So this will be the method of finding the value of the double integral over the rectangle. So you can either integrate with respect to x first. When you integrate with respect to x first, you have to keep that y as a constant. And similarly, in case if you integrate with respect to y first, then in that case you have to keep x as a constant. Now let me come to the next problem. Here the region of integration is no more the rectangle, but it will be some other region. So evaluate double integral xy into x plus y dx dy over the domain enclosed by y is equal to x square and y is equal to x. Now here you see that y is equal to x square. If you construct a table, you will see that these are the points. So when x is equal to 0, it will be 0. y will be 0. When y is equal to 1, that is this point, there will be two values of x, plus or minus 1. So it will be here and here. When y is equal to 4, that means this one, then there are two values of x, minus 2 and plus 2. So it will be this one. So it represents a parabola like this. And then y is equal to x is nothing but it is a straight line which passes through the origin. So when x is equal to 0, it will be 0. When x is equal to 1, it will be this one. When x is equal to 2, it will be 2. And so on. So you'll get, if you draw this straight line, it will be this one. So now what we need to find is evaluate the double integral over the domain enclosed by this one. So this shaded region here is the region enclosed by, this is y is equal to x and this is y is equal to x square. So here let us find out what will be the value of this double integral in this region. So for this one, you see that the point of intersection of these two curves, y is equal to x square and y is equal to x, is at x is equal to 1. So here you can just draw a line, this x is equal to 1, which is the point of intersection of these two. Now we know that this on the y-axis, x is equal to 0. So here let us find out, and here you see that this is the line, y is equal to 0. Now let us see what will be the limit of integration in this case. So here the value of this double integral now, it will be x varies from where to where, because you see that this region here is bounded by this line here and it is bounded by this line x is equal to 1, and on the left it is bounded by x is equal to 0. So the limit of integration for x will be from x is equal to 0 to x is equal to 1. And for y, you can see that this region, shaded region here, below it is bounded by what? It is bounded by this curve, y is equal to x square. So that means the lower limit for y will be x square, y is equal to x square, and above it is bounded by this line, which is nothing but y is equal to x. So therefore the value of this double integral over this region enclosed by this curve, y is equal to x square and y is equal to x, that is over E, is equal to integral x is equal to 0. On the left it is bound to x is equal to 1. And below it is bounded by this curve, this region is bounded below by the curve y is equal to x square to y is equal to x. So in this case you have to note down that since the limit of y is in terms of x, so what you have to do is you have to integrate first with respect to y first. And then after that only, after substituting the limit of integration, then you have to integrate respect to x. So this is equal to integral 0 to 1, then integral y is equal to x square to y is equal to x. Now here x is a constant, so when you integrate respect to y first, then you have to keep this x as a constant. So you multiply that one, or you can bring this one here, x dx here, then the rest will be yx plus y square dy. So always remember that if the limit of integration for y is in terms of x, then in that case you always need to integrate with respect to y and then later with respect to x. However, if the limit of integration for x now is in terms of y but for y in terms of constant, and then in that case you need to integrate first with respect to x and then later with respect to y. But in this particular problem, since the limit of integration of y is in terms of x, so let us integrate with respect to y first. So this is called integral 0 to 1 x dx will remain as it is. So what is the integral of y x dy? Keeping x as a constant. So integral of y dy will be y square by 2, x acts as a constant, so you have to write it here, plus integral of y square will be y cubed by 3, then y is equal to x square to y is equal to x. So this is called integral 0 to 1 x dx. Substitute upper limit and lower limit. So x by 2 will remain. Therefore y replaced by y square, so it will become x square whole square plus it will be x square whole raised to 3 divided by 3 minus the lower limit. Lower limit, it will be x into, now you have to replace y by x, so it will be x into x square by 2 minus y has to be replaced by x, so it will become x cubed by 3. So now you can see from here that it is integral 0 to 1 x Now x squared whole square will become x to the power 4 into x. It will be x to the power 5 or x to the power 4. Sorry, x to the power 5 by 2 plus here it will be x to the power 6 by 3 minus here it will become x cubed by 2 minus x cubed by 3. Now next you multiply this one x inside this one, so it will become x to the power 6 by 2 plus x to the power 7 by 3, x into this one it will be minus x to the power 4 by 2, minus into minus will become plus, with this x then it will become plus x to the power 4 by 3 dx. And this reduces to a single integral with respect to x only. So as usual you integrate this one and then you'll get the area of the region of this shaded region bounded by y is equal to x square and y is equal to x. Now hope it is clear how to find out or evaluate the value of double integral over the domain enclosed by some region, by some rectangle or by some other curve.